Now let's take a look at reflections for our exponential functions. This one is also combined with a vertical shift, so that will make our graph slightly trickier. Starting with our domain, again, all real numbers, no matter what transformation we do to our exponential function. Our range is based on any vertical shifts, which we're going down one, as well as any vertical reflections. We also have a vertical reflection, so our graph will be below the x-axis, or in this case, below our asymptote. So our range will be y is less than -1. Again, jumping down to that asymptote, this time our asymptote will be y equals -1. X-intercepts, our range is y is less than -1, so our graph still will not cross the x-axis. And our y-intercept, substituting 0 for x, and evaluating. We get 2 to the 0 power is 1. Make sure you recognize that that negative is multiplication by -1. So exponents come first, so we get 1, and then multiply it by a negative. -1 minus 1 is -2. So we have a y-intercept of 0, -2. If you had forgotten that rule where exponents come first, or if you thought the negative was grouped with the 2, and you got 1 minus 1 for a y-intercept of 0, make sure you understand that doesn't make sense with our range, where y is less than -1. Quickly generating that t-chart for our parent function. 2 to the negative first power is 1/2. 2 to the 0 power is 1. 2 to the first power is 2. And 2 squared is 4. Sketching our asymptote at -1. This time we need to modify our y value twice. First of all, we're going to multiply it by a -1 for that reflection, and then we'll subtract 1. So order of operations, we'll multiply first and then subtract. So -1/2 minus 1 gives us the point -1, -3/2, or -1.5. We already know that our y-intercept is at 0, -2. Multiplying our 2 by -1, we get -2 minus 1 is -3. And -4 minus 1 is -5. This time I'm going to be careful not to curve away from my asymptote. So we get a vertical reflection and a shift down 1. And our last one, we have a horizontal reflection and a horizontal shift. Be very careful with these. What you have to do before you can use the asylum analogy is factor out any multiplication that's being done to the x from the shift as well. So this becomes a horizontal reflection and a shift right to. Domain, all real numbers. Range, it was a horizontal reflection and a horizontal shift, so that does not change our range. Y is greater than 0. And our asymptote is y equals 0. We still have no x-intercepts because that asymptote didn't change. And the y-intercept, substituting 0 for x. Into the original function, or you can use that factored function if you want. Of course, the opposite of 0 is still 0, so we get 2 squared, which is 4. So we have a y-intercept of 0, 4. Using that t-chart for our parent function again, 2 to the negative first power is 1/2. 2 to the 0 power is 1. 2 to the first power is 2. And 2 squared is 4. This time we're affecting the x value twice, multiplying it by a negative, and adding 2. Order of operations, we'll multiply first. So we have 1 plus 2 gives us 3, 1/2. 0 plus 2 gives us 2, so we have a point of 2, 1. -1 plus 2 is 1, so we have a point of 1, 2. -2 plus 2 is 0, so we have a y-intercept, which we already found, of 0, 4. So notice the horizontal reflection on this one it looks like our graph is decaying. This time I'm going to start the asymptote again, trying to get as close to that line as possible without curving up. So again, this one was shifted to the right too, and a horizontal reflection. So that's why this graph looks like a decay instead of a growth function.